CVE 2025-68613. Learn how to providers can exploit vulnerability in n8n.
In this room, we will examine CVE-2025-68613, a critical vulnerability in n8n that was published on December 19, 2025, with a CVSS score of 9.9. n8n is an open-source workflow automation platform designed to visually connect applications and services for task automation. Users build workflow composed of nodes, with each node representing actions such as making an API request, processing data, or sending an email. n8n is frequently used to automate repetitive operational tasks and integrate security tools and SaaS platforms. Below is a simple example workflow that allows us to schedule an HTTP GET request to the NVD CVE API, format the output using JavaScript, and then send a report via email and to a Slack channel. The n8n platform is commonly deployed in three primary configurations: self-hosted instances, organizations deploy n8n on-premises or in private cloud environments for full control and data sovereignty; cloud-hosted n8n.cloud managed service offering shared infrastructure; internal automation tools deployed within corporate networks to automate business processes between internal and external systems. Version 0.211.0 through 1.120.3 contain a critical remote code execution (RCE) vulnerability within a workflow expression evaluation system. If exploited, this flaw enables an authenticated attacker to execute system level commands, potentially leading to data breaches, service disruptions, or full system compromise, all with privileges assigned to the n8n process. In this room, we will discuss the technical aspects of this vulnerability, demonstrate exploitation by a web browser, and explore detection strategies. This vulnerability is addressed in versions 1.120.4, 1.121.1, and 1.122.0. To ensure system security, it is essential to update to one of these patch versions.
Before exploring the exploit, let's review n8n. It's built on an Node.js using JavaScript for the platform internals and user workflow logic. Its architecture includes workflow execution engine, expression evaluation system, code nodes, 400 native integrations. So, the vulnerability resides in n8n workflow expression evaluation system, where expression supplied by authenticated user during workflow configuration are evaluated in an execution context. The core security flaw is the expression injection vulnerability that enables authenticated attacker to execute arbitrary JavaScript code with the privileges of the n8n process. n8n process user wrapped in a double curly braces as a JavaScript code without adequate sandboxing or input validation. The expression evaluator lacks proper context isolation, allowing attacker to escape intended evaluation sandbox. Authentication provides no meaningful protection against the vulnerability, as any authenticated user can exploit it. We have seen the function return this process main module required child process execution ID to string. Let's see. Let's take a closer look to better understand this exploit. Function is called, it started with return statement. If you aren't familiar, this will most certainly return some kind of object, but here we have string. Evaluation, in case evaluation starts with this evaluation string. The exploit uses this main module. Let's break it down. This refers to global object of the Node.js execution context. Process is a Node.js global object providing access to system processes. Main module refers to root module of the Node.js application. This aims to bypass typical JavaScript sandbox restriction by accessing Node.js internal the root module, which should be unavailable to user expressions. It should be noted that if proper sandboxing is in place, it would isolate the execution context from the Node.js runtime environment. Now that main module object is reached, we see required child process uses require module loads function in order to load child process. The core Java Node.js module for execution system commands. It should be noted that user expression should never have access to Node.js module system, especially dangerous like module's child process. Reaching this far is trivial task to execute system functions. This example implore payload uses exec sync ID. Like if we have used this one, this is it. This is ID. Maybe. So let's say we have a node in here and we are trying to emulate this one. Trying but not succeeding. This is the function, and here how you can see the content of it. So this is it. This is what we are told in here. That ID can execute any bash command in our case. So now that we have executed ID on the target system machine, you can see how easy it is. This payload uses toString to convert the buffer output exec sync to a readable string ID output. Security boundary breach. User expression should never have access to Node.js module system, especially dangerous modules like child process. So now it starts. To summarize, escalation chain when S follow. It starts with the expression evaluation intent sandbox. Then it escalates to Node.js global context via this. Furthermore, it escalated to module access via process main. Module require And finally, the accelerators to the child process. And this exploit, what is the name of module that allows us to execute system commands? Zigzag, I guess. Nope. Request child process. That's it. Now let you can start the end by clicking. Okay, I just clicked it on the attack. I can. Let me see. Okay, we have this. Shape. So now the time of exploit. So let us take this one. Welcome. What do we need here? At first step, and we have manual. Nipple trigger. Okay. Now with it we have manual trigger. We need to set parameters. Has no parameter. Okie doke. Nope. Clicking. Mode. Add field. fill set. Manual mapping. Add fill. Object string. So now we have to execute this one. This will execute the function. ID execute step. Don't execute it successfully. Wait. So the only thing that was missing for the copy paste part, we can see the node is executed. Basically now we can get the flag. Let me see which one. Call root text, I guess. Or no text. No. Home user. Node. What is the flag? Yeah, what is the flag? Let me see this one. Node, okay. Node. Dude. Flag DSP. Cut this one. And copy this one. Very good. So now, this portion of the room will provide details on how to detect this one. Unfortunately, n8n solution does not provide details. Leveling of lock. We can detect this one by below solution sample configuration to nginx to lock body content request body. This is Sigma rule. So experimental, TryHackMe. We have this process main module, child process, and the drink. Select only request, rest, post monitoring. And we have this one. Okay. This is it. Good room. Thanks for this one. Oh wait, the Sigma rules are detected. All the bash and stuff. Here we can see the baddies. All the bad extensions. And here we have the main trusted queries. Go for Sigma rules. Very nice. Thanks for this room. So, bye bye.